This is the last video in chapter 4. It's section 4.7, inverse trig functions. Here are the objectives, and you can take a moment to read through these, but here's basically what is going to happen in this section. Now we're going to be given something like tangent of theta is equal to 3/4. Well, previously, this value was something on the unit circle, and now it's not. And so the reverse is going to happen, and what we want to do is we need to find this angle given the value. And in order to do that, we will apply the inverse of these trig functions. So here's a very, very brief review on inverse functions. In order for a function to have an inverse, it must be 1-to-1, which means it's going to pass the horizontal line test. So if you look at this here, this is the graph of the sine function. And if I draw a horizontal line through it, like this one here, we can see that it crosses the graph more than once. So it fails the horizontal line test. And so the graph of sine is not a 1-to-1 function. So what we need to do is we need to restrict the domain so that I'm only looking at a part of the function in order for the inverse to occur. Because you might be thinking, hey, I have seen this button on my calculator, so I know there's an inverse. And you're right, there is. So when we restrict the domain for sine of x, we restrict the domain to -π/2 to π/2. And so we're only looking at this one little section here of the graph. And this graph will in fact pass the horizontal line test. So now it's 1-to-1 and we're happy. So a few things to mention about the inverse sine function. Basically, these two pieces here is the notation. Now it's important to note that this does not equal 1/sine of x. This is not an exponent. This is solely notation. You may recall that 1/sine of x is really cosecant of x. So it's important to know that these are not equivalent. So we will either say the inverse sine of x or arc sine of x. And I want to remind you that in order to find an inverse, you may recall that we flip-flop x and y and then solve for y. So this here means equivalent to. So these are basically the same thing. So originally we had this. Well, we just flip-flop x and y. Okay. A couple other things to notice is now these ordered pairs, since we're flip-flopping x and y, this ordered pair is now 1, π/2, which is the opposite of what it was before. And this ordered pair is -1, -π/2, again flip-flopping x and y's. It'll be helpful later on, but I typically make a coordinate and say that when we are dealing with inverse sine, we are interested in these two quadrants. Okay, and these two quadrants are the ones that are in between -π/2 and π/2. So this is where the positive inverse functions lie, and then the negative. And that's kind of mentioned on this page here. So again, when we are evaluating an inverse trig function, we are looking for an angle. So we want an angle in between or in one of these two quadrants, positive, negative. Let's look at some examples. Okay, so here's what we are wanting to find. I'm just going to say let y equal sine inverse of -1/2. Okay, so let's go back a little bit to our previous lessons, and we are interested in the angle. So what angle, here, let me write this down. What angle has a sine value of -1/2? Okay, well, if you think of the unit circle, you should come up with pi over 6. Okay, so multiples of pi over 6, but it's negative, so we want the multiple of pi over 6 in quadrant 4. Well, there are really an infinitely many number of values in which this occurs, but we need to be very specific that our value is in between -pi over 2 and pi over 2. So in this quadrant, normally you might be thinking that, let's see, 11 pi over 6, but 11 pi over 6 is not in the interval from -pi over 2 to pi over 2. But if I write this as -pi over 6, then I am in this quadrant, and it is a value in between -pi over 2 and pi over 2. Let's look at the next one. In this one here, ask yourself what angle, because again, we are finding angles, what angle has a sine of √3/2? Okay, well, this is multiples of pi over 3. And here, this happens to be a value in between -pi over 2 and pi over 2, so I'm golden. Okay, well, in this next one, if I let y equal this, I want to know what angle has a sine of 5 pi over 4. Well, this is a problem because 5 pi over 4 is greater than 1. And on our previous slide, we know that this value has to be in between -1 and 1, and it's not. So this value does not exist, and it's undefined. Let's take a look now at the inverse cosine function. So again, the original function, y equals cosine of x, is the one in gray. This fails the horizontal line test. So again, we restrict the domain. So we're looking at this little blue part here. And this ordered pair is 0, 1, and this one is pi -1. So when I calculate the inverse cosine function, I'm going to flip-flop all x and y values and end up with this. So when I flip-flop those values, this is -1 pi, and this is 1, 0. So these pieces here are important. I am interested in the interval 0 to pi, which are these two quadrants. Inverse tangent, again, we restrict the domain because as is, it fails the horizontal line test. So here, when we restrict the domain, we restrict it to -pi over 2 and pi over 2. Those endpoints are not included because of the asymptotes. And it's addressed here. So Just to kind of follow along, here's negative pi over 2 on the unit circle and pi over 2. So we only want these values. Okay. Onward. Let's look at some examples. Okay, so this is going to be important. So if I want to find arctangent of 1, ask yourself what angle, because we're always finding an angle, what angle has a tangent of 1? So you, if I say this is y, I can write this another way. I can say tangent of y is equal to 1. All right, so you should be able to come up with y being pi over 4, right? So you need some multiple of pi over 4. Well, remember with tangent, tangent is positive in this first quadrant, so pi over 4 is correct. All right, look at the next one. What angle has a cosine value of -1/2? Okay, so if I say cosine of y, so if this is equal to y, I can rewrite this and take the cosine of each side. So cosine of y is equal to -1/2. Okay, well, cosine of y is 1/2 at multiples of pi over 3. But remember, cosine has to be in one of these two quadrants. So since cosine is negative, we can't just put a negative pi over 3 because that puts us in quadrant 4. So we need to come up with the multiple of pi over 3 that's in between 0 and pi. That is a multiple of pi over 3. So, but this is in quadrant 2. So this would be 2 pi over 3. Here are some more examples. In this example 6, ask yourself what angle has a cosine of √3/2. Hopefully you came up with multiples of pi over 6, but remember arc cosine is in these two quadrants, and pi over 6 is positive, and that works fine in quadrant 1. In number 7, what angle has a tangent of 0? Well, remember, tangent of theta is equal to sine of theta over cosine of theta. So when you ask yourself what angle has a tangent of 0, well, that means sine needs to be equal to 0. And sine, pardon me, is equal to 0 here and here. So 0, pi, 2 pi, so on and so forth. But remember, tangent has to take place in between these two quadrants here. And the end points are not included. And so right here is the answer, so 0. Take a look at this set of examples. Here, if we follow the same process, we would ask ourselves, I'm really sorry, my puppy's cuckoo, hang on. Okay, we would ask ourselves, in this first example, in number 8, we would ask, what angle has a cosine of 3/5? In this one, we would ask, what angle has a sine of -0.457, so on and so forth. Well, these values are not on the unit circle, so we're required to use the calculator to solve these. So on your calculator for arc cosine, you will use this button here. So you'll type in this. Now, Sometimes we want to work with radians and sometimes we want to work with degrees. So if you want your answer in degrees, you need to be in degree mode. If you want your answer to be in radians, you need to be in radian mode. So pause the video and try each of these and see if you get the correct answer. So in number 8, you should have 53.13 degrees or 0.927 radians. In number 9, you should have negative 27.194 degrees or negative 0.475 radians. In number 10 here, you should have negative 64.43 degrees or negative 1.125 radians. Now, sometimes we encounter applications in which we use the inverse trig functions to find the value of an angle, but the desired angle is not in the range of the inverse functions. So if this is the case, we basically will end up kind of using a reference angle in a way. And let me show you what I mean. So a couple things to point out. It says to use a calculator and find the degree measure. So we will want to be in degree mode. And we want to find an angle. So we know we're going to need to use an inverse trig function. And we want our angle to be in between 90 degrees and 180 degrees. So here's 90 degrees, this is 180 degrees. So I need my angle to be in quadrant 2. So here's how we will solve this. Since I want to find this angle, basically what I'm going to do is take sine inverse of both sides. And I'm finding, so sine and sine inverse will cancel, which we'll find shortly. But theta is equal to sine inverse of 3/8. So go ahead and type this into your calculator. Since we want it measured in degrees, you should be in degree mode. And you should find that theta is equal to 22.024 degrees. Well, you should know by now that this is actually in quadrant 1, which is a problem. So again, this becomes kind of like our reference angle. Not exactly, but kind of. We need to take the sine of this lightly. So if I want to find the angle in quadrant 2, I need to take 180 minus my reference angle, so minus 22.024 degrees. And this is approximately 157.976 degrees. The directions say to measure to 1 decimal place. Well, that rounds this up to approximately 158 degrees. Let's look at some more examples of this. Okay, so this is the same type of problem, but there are 2 of them. And one thing to notice is this angle is in degrees. And in this one, we are in radians. So you do want to be cautious of the mode that you're in your calculator. So in this example, 180 degrees is here. 270 degrees is here. We want our angle in between those, so we want our angle in quadrant 3. So, like the previous example, we are going to take sine inverse of negative 3/7, and this will give me theta. So again, I want to be in degree mode since I want my output to be in degrees. I find that theta is approximately negative 25.377 degrees. Well, this is actually in quadrant 4, and I need an angle in quadrant 3. So if I want an angle in quadrant 3, I need to take 180 and add my reference angle to it. So I will take 180 plus my reference angle, and this is where I mean reference angle lightly, because I don't want this negative sign, because if I add a negative 25.377, that's going to put me back into quadrant 2, not quadrant 3. So I'm going to add a positive 25.377, and this gives me an angle of 205.4 degrees, which is in fact in quadrant 3. Okay, in part B, we know we need to be in radian mode. Pi over 2 is here, here is pi, so I want a value, an angle in radians in quadrant 2. So theta is equal to tan inverse of negative 8/3. Make sure you are in radian mode in your calculator, and you will find that theta is approximately negative 1.212. Again, not in quadrant 2. So if I want an angle here, I need to take pi and then subtract this angle measure. So in quadrant 2, I'm going to take pi minus 1.212, and this is approximately 1.9296. All right, so here we are taking composition of functions, and basically this is a function within a function, kind of like a turducken, but mathematically speaking, of course. So basically what happens is, as long as x is within these as long as x satisfies these values, basically what happens is these trig values, since they're inverses of one another, they cancel out and they just leave you with x. There are a few catches to this, and it does get a little confusing. So just practice a lot and be cautious of the quadrants in which the trig functions can occur. So let's just jump into some examples. So looking at this, I have arc sine and sine. So these should be able to cancel one another out, leaving me with negative pi over 6. Well, remember with arc sine, whatever my output is for arc sine, it needs to be in one of these two quadrants. So it has to be in between negative pi over 2 and pi over 2. Well, negative pi over 6 does fulfill that requirement, so we are golden. Now, part B is a little bit different. Part B, I can't just cancel these out because then I'm left with 7 pi over 6. This is a problem because 7 pi over 6 is in the second quadrant, and I just told you that we need an answer in one of these two quadrants. So we need to be careful. So wait, hold on. Now, in 7 pi over 6, we know that sine is negative in this third quadrant. So that means since my answer can only come from quadrant 1 and quadrant 2, I need to pick the quadrant that produces a negative value for sine. And the quadrant that produces a negative value of sine is quadrant 2. So I need a multiple. Now, my reference angle is pi over 6. I need a multiple of pi over 6 in quadrant 2. Okay, well, in this case, you don't want 11 pi over 6 because that is not in between negative pi over 2 and pi over 2. Instead, you want negative pi over 6 because that fulfills all of the requirements. Let's look at some more. Okay, well, here, the cosines cannot just cancel out in this case either. So remember from our previous example, 7 pi over 6 is here, but cosine inverse can only be in one of these two quadrants. So cosine is negative here. So we want the negative quadrant that are our two possibilities. So we want an angle in quadrant 2. It has to be in between 0 and 2 pi. So the angle, 0 and pi. The angle in quadrant 2, that is a multiple of pi over 6, is 5 pi over 6. All right, in part B, I can cancel these out and it leaves me with my answer of -1/2, because remember with cosine, we need a value in between -1 and 1. These examples are a little bit different because now the two trig values are not inverses of one another. So now I have cosine of sine inverse of 40 over 41. Now I want to remind you that whatever this is, it ends up being an angle. Call it theta. So theta is equal to sine inverse of 40 over 41, which means sine of theta is equal to 40 over 41. So I need to figure out how to find cosine of theta, because if this argument represents theta, ultimately I want to find cosine of theta. And if I can do that, I'll be able to answer the question. So what we need to do is we need to draw a triangle. Sine inverse is positive in this first quadrant. And I can apply a little bit of SOHCAHTOA, and I know that the opposite is 40 and the hypotenuse is 41. I can use the Pythagorean theorem to find the missing side, which ends up being 9. If I have this triangle, I can find any of the 6 trig functions. And in this particular case, I want to find cosine of theta. So according to SOHCAHTOA, cosine of theta is the adjacent over the hypotenuse, which is 9 over 41. Let's try another one. Now, in this next example over here, the only difference is that this is a negative. So this will still represent some angle, call it theta, and so we still want to find cosine of theta. The difference is the quadrant in which this angle is drawn in. Remember that sine inverse is negative in this fourth quadrant. So applying SOHCAHTOA, this would be -40 because the hypotenuse is always positive. and then apply the Pythagorean theorem to find the missing side. And we've already done that in the previous example. So if I want to find cosine of theta, it's the adjacent over the hypotenuse, which is 9/41. I kind of like these, not too bad. Try this one on your own. So tangent is positive in the first quadrant. So using SOHCAHTOA, this is 5, this is 12. Applying the Pythagorean theorem, you should find that this is 13. So this represents an angle. So sine of theta is what we want to find. SOHCAHTOA says that this is 12/13. Done. Same thing here. This represents an angle. Sine is negative in this quadrant, in quadrant 4. I'm really sorry about my puppy, you guys. Please just bear with me. Let's see. So setting this up, this is -2 because the hypotenuse is always positive. Using the Pythagorean theorem, we find that this is the square root of 117. So cosine of theta is equal to the square root of 117/11. Done. Well, of course, we are here at Bellevue University and we like real learning for real life. So here is a real life application. Why don't you pause this and see if you can set up this problem? All right, so let's say the sun is up here and the sun is shining on this beautiful Eiffel Tower. And we know the height of the Eiffel Tower is 1,063 feet tall. We also know the length of the shadow is 310 feet. And we want to approximate the angle of elevation, this angle here. So if I'm looking at this, this is a right triangle, so I can use right triangle trig and use SOHCAHTOA. So if I want to use SOHCAHTOA, I want to notice that with respect to theta, I have information with the opposite and the adjacent. So if I write SOHCAHTOA down, I have the opposite and the adjacent, which means I'm going to be dealing with tangent here. In fact, tangent of theta is the opposite over the adjacent. So, since I'm finding that angle, I want to find tan inverse of this value, and this will equal theta. So, let's see. Since we want, typically we deal with degrees. So it tells us to measure in degrees. So make sure your calculator is in degree mode. And you should find that we end up with an angle measure of 73.7 degrees. Here's another real life example. Pause the video and see if you can come up with this one. Okay, so really we are just focusing on this triangle here. If it's a rectangle, we know that this is 16 feet also. So 16 and 6. With respect to angle theta, we know the opposite and the adjacent. So once again, we are going to be dealing with tangent. Tangent is the opposite over the adjacent. So if I want to find this angle measure, I'm going to take tan inverse of 6/16 to find theta. And I want to be in degree mode. And I get approximately 20.556 degrees. Since I want to round to the nearest tenth, this is approximately 20.6 degrees. So certainly not terrible. Now, so far, we've really only talked about inverse sine, inverse cosine, and inverse tangent. And of course, there are 3 other inverse trig functions. And I'm really just going to kind of briefly go through all the definition stuff and then just really hit some examples. So we're going to first start with inverse secant. And so remember that it needs to pass the horizontal line test. So we're restricting the domain. And we end up focusing on the interval from 0 to pi over 2 and then pi over 2 to pi. So really it's this interval, but pi over 2 is not included because of the asymptotes. So secant will be positive in the first quadrant and negative in the second quadrant. Cosecant, when we restrict the domain, you will find that cosecant is in between these quadrants, which is denoted here and here. So in between negative pi over 2 and pi over 2, but those endpoints are not included. And then finally, we have cotangent inverse, and with this one, we are in between 0 and pi. Okay, so let's just jump into some examples with these. Okay, so here in this first example, I just want to remind you, you're asking yourself, what angle has a secant of 2? Well, if secant is 2, that means cosine of theta must be 1/2. So what angle has a cosine of 1/2? That's pi over 3. Now remember, secant inverse must be in one of these 2 quadrants, and it's positive in the first quadrant, so this answer is right on. In this next example, we're asking what angle has a cotangent of negative √3? Well, remember tangent and cotangent are reciprocals, so this means what angle has a tangent of negative √3/3? Okay, now a couple things to mention. Cotangent must be a value in one of these 2 quadrants. Cotangent inverse, it's negative, so we need an angle in quadrant 2. Now, tangent of theta is equal to negative √3/3 at multiples of pi over 6. In quadrant 2, that is 5 pi over 6 because it's not quite 6 pi over 6. All right, cosecant inverse is in one of these 2 quadrants. Since it is negative, we need a result in quadrant 4. So we ask ourselves, what angle has a cosecant of negative 2√3/3? Well, this tells us that sine must be negative √3/2, again, because they are reciprocals. So this is multiples of pi over 3, but we are in quadrant 4. So we need a multiple of pi over 3 in quadrant 4. I do not want to use 5 pi over 3 because it has to be a value in between negative pi over 2 and pi over 2. So instead, I will use negative pi over 3. That's equivalent to 5 pi over 3, remember from one of our first few lessons. Here it says use a calculator to approximate this in radians. So we need to make sure we are in radian mode. Well, you're probably thinking, oh, well, there's no cosecant inverse on a calculator. There's not that button, and you're right. So then you might be inclined to type in 1 over sine inverse of 8/5. Well, if you type that in, your calculator is going to give you an error. So we need to come up with something different. So just kind of bear with me as I explain this to you. Okay, so let's take baby steps. If we want to find cosecant inverse of 8/5, that means we want cosecant of theta to equal 8/5. We want to find the angle that has a cosecant of 8/5, right? Well, this implies that 1 over sine of theta is equal to 8/5. And the reason I know that is because cosecant is equal to 1 over sine. Same thing, right? Okay, well, I can solve this by cross multiplying. And when I cross multiply, I end up with 8 sine of theta is equal to 5. Divide by 8. So sine of theta is equal to 5/8. Okay, now I probably should have mentioned from the get-go that cosecant inverse has to be in one of these two quadrants. Okay, and since it's positive, I need something in quadrant 1. All right, well, we've just determined that cosecant of theta equal to 8/5 is equivalent to this. So I can find this angle by taking sine inverse of 5/8. I can plug that in my calculator and I end up with 0.6751. This is a value in quadrant 1, so I'm good to go. Let's try a couple more examples to make sure that you do have the handle of this. Okay, in our first example, we have secant inverse. So you might want to remind yourself of which two quadrants secant inverse can be in, and it's these two quadrants here. It is negative, so we want to make sure that our result is in quadrant 2. Okay, so let's see here. This is the same thing as writing secant of theta is equal to -4. Okay, so this tells me that I can rewrite secant as 1 over cosine of theta. Those are equivalent. So I can multiply both sides by cosine and then divide by 4. And I end up with cosine of theta is equal to -1/4. I can then take cos inverse of both sides, and I find that theta is equal to cosine inverse of -1/4. And I can plug that in my calculator. And since this tells me I want to be in radians, I need to be in radian mode. And I get 1.8235. Now you're probably thinking, how in the world do I know if that is in fact in quadrant 2? Well, remember this is pi over 2. So if you plug pi over 2 in your calculator, it's 1.5707. And this is pi, which you should know is 3.14. This value is in between those two values, so I'm good to go. Remember, if this is not in those between those two values, you use it as a reference angle in a sense. Let's take a look at this last example. Okay, Cotangent inverse is in one of these two quadrants. It is negative, so we need a result in quadrant 2. So we can rewrite this as cotangent of theta is equal to negative 5/12. So rewriting this as 1 over tangent of theta is 5/12. Cross multiplying, I end up with tangent of theta is equal to, I lost my negative 12/5. So theta is equal to tan inverse of negative 12/5. This is a button on your calculator. When you calculate this in radian mode, you get negative 1.76. Okay, well, this is a problem because this is not in quadrant 2. So you need to use this as a reference angle in a sense. So we need to get into quadrant 2. So what you're going to do is you are going to take pi minus whatever this angle is. And again, remember, I use this reference angle term loosely because of this sign here. You don't want to say pi minus a negative 1.76 because that will actually put you in quadrant 3. So we are going to take pi minus 1.76, and this is going to give us a value of 1.9656. This is in quadrant 2. This concludes all of the information from chapter 4.